December 14, 2008, I learned the meaning of safety leadership. In BAPCO, in one of the crude units, we had, I'm willing to admit, we had a fire. But it wasn't a hydrocarbon fire. We had put some scaffolding around it, and unfortunately, some of the planks that were used in the scaffolding, they started to burn. It looked a bit spectacular. Our firefighting force was there, and they were trying their best to put it out. But one gentleman who was leading them, Ahmed here, when he saw a little bit of a struggle going on, he put all of his gear on top, took the hose, went up there, and that particular day, he knew where the seat of the fire is and put it out in no time. That crude unit would have been $83 million. This is what safety leadership is. It's not just knowing the stuff when the call comes to do it. So I always feel privileged whenever I'm in Ahmed's presence. I took your time, so sorry. I am going to talk about a very curious aspect of human factors and its role in incident causation. I'll go through a very brief description of what our journey in operational reliability is and some of the special challenges we have, and then I'll come to that. I don't need to go to the BAPCO introduction. Maybe you already know very well. It was this morning. What I need to concentrate on is this simple diagram. It looks simple, but in terms of its conceptual power, this is one that really captured our imagination. That if you want to build, if you want to assure reliability, whether it's organizational or your entire company, then you have to start with a solid base in terms of design. If you do not have proper engineering standards, if you do not have proper safety standards, according to which you actually do everything, and according to which you do engineer stuff, then you could have all kinds of other buildings on top, and they will all be shaky because your foundation is shaky. So one of the things we did in our major projects was that we created a very fantastic set of what we call BMPS, BAPCO Modernization Program Standard Specifications. That became major requirement. Now, then on top of that, there's the equipment reliability, the processes reliability, and people reliability. And somebody very cleverly changed the height of these arrows because they were very rightly trying to say that the people reliability part of it really is quite fundamental and is very important. So with this in mind, this particular model in mind, we tried to look at what our challenges in BAPCO were. And I got a question this morning, those of you who were there, about the equipment age. Yes, the equipment age and reliability has a relationship. We did carry out that type of analysis, and as you can see, we have a large number of or percentage of our assets that are fairly old. The increasing rate of failures is a known factor. Corrosion, erosion problems can occur. However, we said to ourselves, let's put this into focus. We looked at the incidents in past 10 years for per 1,000 assets. Again, the story emerged that more number of the older equipment were involved in the incidents that we were recording. So the 60 to 70 year age group and the 70 to 80 year age group, that's where per 1,000 pieces of equipment we were feeling that. We looked at the work orders also. The distinction was not that great as the number of incidents you saw. But what it means is that even the Younger equipment requires scheduled maintenance and work orders get generated due to that. We didn't take those out. But the trend is still there. It's a little bit high on the 60, 70 age group. In terms of human part of it, human nature is really quite tricky. You cannot really, the mystery still persists. I mean, I'm going to give you a very small story. There's a cross-country pipeline in the middle of the desert. It runs for about 100 kilometers. This is good old days. We just used to put dirt cover over it, and it was full of oil. It was flowing with oil. And we gave a person a nice truck, and we said, look, your job is that twice a week you drive along this line, and you see if it's leaking anywhere or not, and all you have to see is if it's brown patching somewhere, you will know that something is leaking. That was all his job. But we found that he was charging for fuel, he was charging for lunches, dinners, his receipts were okay. But a lady in a bus traveling about on that particular road, about 200 meters away, noticed a large patch, and she told her husband that she saw a large patch of brown around that. There's something going on. So if that guy was doing his job, he would have spotted that particular leak ages ago. But if you give somebody that kind of a task, which really doesn't have the direct meaning, doesn't have the direct responsibility, and you're not assured that he understands what he's trying to do, then he's going to find a way not to do it. Human factors, in terms of there are sort of major new developments, and Ian's work and the people who are doing this kind of a work, I really admire it. What we industry people tend to do is we use our knowledge. We think we know, we know psychology. All of us are psychologists 101. We deal with people, we deal with children, we deal with students, we deal with colleagues. So we think we understand. When it comes to do formal reliability and how humans will behave, my advice to you is leave aside your homemade thoughts, your personal biases and experiences. Look for the professionals, because this is a vast field. They've done the task, they've done the thinking for you. Please, behavior-based safety has made great strides. Again, some people will say, well, it's kind of second nature. It should come to you. People should act safely. Why shouldn't people act safely? But again, there's a role for the specialist to play here. And it is, the devil is in the detail. It's not just the perfunctory services that you provide. It's the attention to detail that the professional can bring to it that will pay you the dividends. I was party to an audit in a major refinery, and my role was to be the fly on the wall, i.e. I wasn't part of the audit team, but I was just an observer. And they had done HAZOPs. Their FCCU HAZOP was 1,100 pages of printed document in 4 volumes. It was all displayed in all beautiful color prints. So I just looked at the first page and saw that they had asked an external chairman to come in and do the HAZOP, which is fine, which is one of the things you should do if you don't have the expertise yourself. And sometimes in HAZOPs, you are actually asked to get an independent chairman because he's not part of the problem like you, he's from outside. But then I had to look at the list of people who were present, the company people, and I just made a quick note of those. And one by one, I started to call them, because this was a HAZOP done only 3 months ago. And I just asked a simple question. 3 months ago, you attended this HAZOP, and this was like a 6-week HAZOP. Can you please remember one thing from that stuck in your mind? And the answer from those 6 people was, oh, we hired such and such consultant, he was the chairman, can you call him? So all 6 company people wanted me to call the chairman to answer this question, that what was the most interesting thing you heard? I said, fine. The OSHA guys had given them full marks, by the way. I mean, the book was very posh. Literally, it was the highest cadre of HAZOP. But I went home, I said, no, I don't want that HAZOP. Anyhow, a refinery had a problem in a pipe thinning. A lot of big fire, a lot of smoke came out, although it was just smoke, but the location of this refinery was such that it cost that company quite a lot of money. And the going in position became, everybody in the company was then told that read API 571 and learn about the 66 mechanisms listed in there of corrosion or erosion or damage mechanism. So that became the new in thing. 2 years, 3 years down the line, I can again ask those people that, do you remember those 66 damage mechanisms? I find very difficult. People to say, oh, maybe, something like that was there. This is the kind of human nature. And the curious part that I'm going to bring to now is our ability to, not our ability, but our wish, our desire to find a solution to any problem. And this is particularly important for me in project management. Because in project management, many times people leave a very, which looks like a very, innocent phrase, that this particular detail will be worked out by the EPC consultant based upon site. I.e., we will do it when we actually come to do that construction. In my way, this is the advent of a word called jugaad. Those of you who are from North India understand that word jugaad. Jugaad simply means that you improvise something, that you make do. It's not the best and not the ideal solution, but it will work. And that is what I'm inviting in a major project. Whenever I'm leaving that line in my design specs, that to be specified or to be done by the EPC consultant when it comes to, because I couldn't be bothered to actually go to site, measure things up, and actually put that design in right now. So what you'll end up with is a jugaad. And that is where the human creation, the human inventiveness will come. I am afraid in my business, which deals with, thousands and millions of barrels of oil and gas and, very, very flammable stuff, jugaad really has no role to play. I would rather have things designed in accordance with standards, in accordance with the known standards that have worked in the industry. Some people will say it saves time, but it can bypass your MOC process, the jugaad can. And even if you did the management of change reviews and things like that, because of the time pressure that projects put on you, it may not be easy for you to actually handle that and get away from it. A simple leak of light material from a line, and the guy actually, they understood that when this line leaks due to Joule-Thomson cooling, the icing will start up, and yes, lo and behold, by the time they went there, the line had iced up, but it was still leaking, but not at a very great rate, but still enough leakage was there. So instead of waiting for his supervisor to find out how best to remove this ice, the guy simply said, look, you're worried about sparks and things, I will get a brass hammer. So he got a brass hammer and he started to knock on the ice. And as a result of that, because there were some other problems also in terms of the material specification, the cold brittle fracture occurred. So which was a small leak, really turned out to a big leak now, and suddenly, there was a huge vapor cloud explosion. And what I mentioned was the 100 largest losses. I mean, that is reported as $400 million worth of asset damage. Just that kind of a couple of hammer blows. One day, a supervisor was going around in the morning, and he saw that a cover plate on a nozzle on top of a spheroid, which contained crude oil. Spheroids are these storage vessels, which are generally low pressure vessels. They're like 3.5 pound or 3 pound maximum. And he saw this cover plate, and that cover plate was rattling, and the vapor was coming out. Yeah. So he said to himself, oh, this is really bad. Somebody's forgotten to tighten it. So he was big enough in the organization, he got that tightened. 15 minutes later, the top third of the spheroid just flew off. Because that day they had sent some high RVP material in it, and that started the RV to chatter, and they had taken the RV off. They had taken it to the repair shop, and as a jugaad, they had put a weighted plate on top of it to act as a kind of a poor man's relief valve. So, jugaad, the Flixborough incident was really a famous designed jugaad that they came up with. There's a human obsession with problem solving. This compulsion really comes from, whether it's built into us, I don't know. But somehow we got to curb that enthusiasm and say, no, I have to do it by the book. One of my old previous bosses used to say, it's the second mouse that gets the cheese. So tried and tested methods are the one that you should use because they have been proven to be right. There are very robust industry standards and recommended practices, API, NFPA. We can all draw from them. As I mentioned earlier, there's excellent knowledge base by CCPS, and this morning I also came across, previously I had come across the ICAME in the UK, but now there's the Australian resource also. We'll go through that. The current mantra is recognized and generally acceptable good engineering practices. Do not deviate from them. Don't try to put Heath Robinson designs. They may sound attractive, they may sound that they've solved your problem, but trust me, they haven't. Okay, can we not really learn from some other industries in terms of reliability who have done it better? Do we do copy and paste from aviation or nuclear industry? Or do we actually take information from them and adopt it? I don't know. I'm not good enough to answer that, but somebody has to think through it, because if those guys can do it, we can do it. Because our safety is now becoming that paramount. The cost of not being safe is becoming so high that mind boggles, really. So in this journey, sometimes whatever is apparent is not really the truth. You have to hunt for it. You have to look for your experts who are with you in the organization. Look to them for the answers. And only then we'll be succeeding step by step, bit by bit. Thank you.